Hey guys, I have something different, slightly different today. I'm actually pretty excited about this. So a company reached out to me after seeing some of the videos I've done lately featuring Ryobi batteries and rebuilding them. And they asked if they could send me some of their third-party batteries for me to check out and hopefully do a video on. So they didn't give me any money, and they didn't give me any restrictions or directions on what to say or post or do. And they also did not ask to see or review anything before posting. So this is going to be completely my own personal opinion on everything. Nothing has been scripted or detailed by them what to do. And they even said if I don't make a video, that's fine too. So they're just hoping I would. And I said, sure, I don't have a problem with that. I think that's kind of cool. I'm a little nobody, essentially, but they liked some of the stuff I was putting out, so they sent me some stuff. So there should be two batteries in here, two 18-volt Ryobi compatible batteries. I haven't opened it yet. I'm going to do everything on camera so that you guys can see the first impressions as I come up with them. In this first video, or this first part, I'm just going to do an unboxing and just kind of first impressions. And I think we will disassemble one of them to take a look at the insides, see how they're constructed. And then I'll do a second part, which will be in the same, like this will all get posted together, but I'll do a second part later after testing. I'll do some capacity testing and some final impressions after a little bit of use on actual tools. So we'll do, just the first part of all that today. So this arrived very quickly. They just reached out to me the other day, and this got delivered today. The brand name, it'll probably be in here. Let me get this open. The brand name, or would you call it a brand name or a not brand name, was Kunlun, Kunlun, I think is what it was. Let's see how these are packed up. Let me see what this says. Yeah, so I don't know. Kunlun, and this is a 2-pack of 6 amp hour Ryobi equivalent batteries. They also have the 40 volt equivalents, or Ryobi compatible, and they also had their own batteries that were compatible with a few other brands. I think I'd have to look again. I think it was DeWalt, Craftsman, Makita, chargers, their own, third-party chargers for all of those as well. So they offer a wide selection of batteries compatible with various brands. The pictures on their listing, and I'll have links below if you're interested in this afterwards, regardless of what my first impressions are. Oh, that's packed in foam. That's a nice first step. The pictures made it look like everything is done with fully compatible circuit boards for safety, as far as the correct monitoring and everything. So there's foam packed around everything, which is great, good to see. So they survive shipping well. This looks like 6 different languages about the product: lithium battery, operating environment, charging precautions, discharge precautions, proper use. Yeah, pretty standard. Set that aside. We've got just some filler paper, and these are both in bubble wrap. All right. So on the top it says RB18L50. Rating 18 volt, 6,000 milliamp hours. Looks like they've got a charge indicator on the front, which claims these are they both? Yeah, they're both at about 50% charge. CDE2304LW. Okay, I don't know what that is. A part number, some kind of other part number, or it's something, not sure. On the bottom here, it says power tool battery, rechargeable lithium ion battery pack, voltage 18 volts, capacity 6,000 milliamp hours, energy 108 watt hours, model RB18L50, and it says replace P102, P103, and a few other model numbers, and then it says etc. And these are Ryobi battery numbers. Warning: to reduce the risk of fire or burns, don't disassemble, crush, puncture, or short the contacts. All brand names and products listed or shown are registered trademarks or trademarks of their respective owners. And then we've got some QC label on the bottom, and this says FCC, lithium ion, UKCA, CE, and don't throw in the trash symbol, made in China. Cool. So right off the bat, we can see that they've got the 3 standard connections up on the top, and they've got another connection down here, which should be another temperature sensor that certain tools and chargers will talk with. It looks like Torx screws holding it together, and they actually don't look like security Torx. They look like standard Torx. So let's start with this. I'm going to just put a piece of blue tape on one of these so that we can remember which one is which going forward. So blue tape, not blue tape. We're going to disassemble one of them now. And then I don't want to disassemble the other one just in case I do something silly on accident and I'm not able to give it a fair discharge test and everything. So we will put, we'll do the disassembly of the blue one. So the blue dot, or the blue tape, is the one we are going to check out and do everything with. And this timing is kind of perfect. I probably will have released it by the time this video goes out. But I just recently took 2 of these Ryobi packs, this one and this one. These are both batteries. These are P104s that I recovered, and they were totally dead. The cells inside of them were not salvageable. I forget what was wrong with each, but these, I bought a spot welder so that I could properly rebuild these now that I'm getting into working on these tool batteries a lot more. And so I rebuilt both of these with brand new cells. And these are now 6 amp hour batteries. I think originally these ones were 2.5 amp hour or something like that. They're quite old. So these ones have both been totally rebuilt. So that I reused the circuit board, but all brand new cells. So these things are basically better than new, since they're a much better capacity now too. So this is going to be kind of the perfect follow-up, rebuilding a 6 amp hour pack with new cells and the Ryobi original circuit board and everything. And then we're going to see what their 6 amp hour battery looks like. Oh, immediately theirs is a lot lighter feeling. It doesn't feel as heavy. I'm not sure how much different. I'll have to get a I'll get a scale and put that information either down below, or try to remember to put that in the next segment that I record. But it definitely feels lighter. Not tons lighter, but lighter. So let's grab our screwdriver over here, and we will do this. My desk, I'm in the process of rearranging everything. Let's see what size these are. Are these 10? Yeah, that's a T10. So my desk is in kind of disarray. I'm rearranging it, making space for more organization. Oh, you know what else I'll do before I get this fully into this? Is we will put a little voltmeter on here and see precisely what voltage they shipped at. 18.1 volts. Check the other one. 18.2 volts. So I don't know if that's going to show fuzzy on screen, but it's really clear. This is a 3D printed thing that I made for these. Just a simple voltmeter and some connections, and then a button here so that you can leave it on a battery without slowly draining it. And that was just a generic like 12 to 24 volt panel. I actually think it goes up to like 30 or something, but volts, but pretty handy to check on stuff, especially if I'm monitoring batteries that I'm repairing or rebuilding to see if they are showing any self-discharge. These look like they're the same size screws around the sides versus in the top of the tower. Yeah, those look the same to me. So lots of people have talked online. If you do any search, and there's always somebody asking about third-party batteries. Are they any good? Are they worth it? Blah, blah, blah. It comes off nice and easy. Looks like there's not really anything going on in the top except for a light guide, it looks like, for the LED indicators. And that's screwed in. What is that? Oh, and then the button that you push is captive in there as well. Definitely feels, it feels maybe a little bit thinner than the official Ryobi stuff, and feels a little bit more, it feels more plasticky, which is not a very helpful description, is it? It feels a little more like that, less expensive, maybe slightly more brittle, if I was just putting a guess by feel. It's got the model number embossed in the front, RB18L50. I don't see any other label or anything on there. If I run a knife, yeah, that just I don't feel any kind of reinforcement in there. It just is like a generic ABS, I'd assume, plastic injection molded something or other, which is not a bad thing. It serves its purpose. What do we got on here? Oh, okay. This is immediately very different than a Ryobi design. Okay, so these come out similar to a Ryobi. Are these captive? No. And then the springs come out. These are slightly different than the Ryobi official. They've got an angled portion at the top and then a straight shank. Most of the Ryobi ones I've taken apart so far are more like a lightning bolt kind of Z shape to them. Do I have any apart that I could show you right now? I don't think I've got any of the other ones taken apart right now, so I'm not going to get into that. But these come out as well. And then I expect that this will just lift out. Yes. In the bottom, same model number embossed, RB18L50. And then some Asian characters I don't know how to read. I don't know if that'll show up on camera. If anybody knows how to read whatever those characters are. Those, yeah, same characters are on the bottom of the lid next to the model number. So I'm not sure. Maybe those are the model number, and or maybe it just means like model number. I don't know. So this is very different than a Ryobi design. Immediately. Let's see. I see we've got balance leads coming down to all the batteries, so that ought to be okay. So that ought to be monitoring the individual cell voltages, which is good for safety. these cells are marked 2 amp hours, which means if these are in parallel, then this is a 4 amp hour battery, not, whoops, did I trigger that? Then this, what just happened? Oh, if I tap the contacts, it lights up. So that means this is a 4 amp hour battery. This is not a 6 amp hour battery. And if you look on here, I'll show, I don't know if that's gonna, if you look on here, whoop, you can see it's supposed to be a 2-pack, 6 amp hour, 18 volt replacement. So it's definitely not, before I even bothered testing it, it's definitely not 6 amp hours based on the labels that are on these batteries. Is there a model number on these to see? CR 18650 20P. ICR 18650 20P. I will try to look up these cells, and we'll talk about it in the next segment or post something. The next thing I want to do, oh, that was sitting on the button, I'm going to check the voltage on each cell and see how balanced they are out of the box. So we have 3.59, 3.61, 3.61, 3.61, 3.58. So those are not bang on, but pretty close. Close enough that I am not uncomfortable about it or anything. So it looks like we've got Mosfets, a whole row of Mosfets up here, which must be doing the switching. These are a lot smaller than the ones that Ryobi Official uses. This is going to be, I feel like I have to, let me reach over here. Let's do this. I'm going to take an official Ryobi shell. This doesn't have any cells in it right now. This one's waiting for me to install new cells, but it's going to be easier if I can show you an example of what I'm talking about is different. Oh, a bit stuck to it. So this is a P102. Yeah, this is a P102, which I also recovered. But once I recovered it, I found that the usable capacity was only a half amp hour, which is not really enough to bother keeping. So I disposed of those cells, and I'm going to rebuild it with new cells. But let's take the circuit board out of this. So you can see here what I'm talking about that is very different. So these are, I'm just going to set these aside. So these wires that are all coming off, these are balance leads. So these would be the same as these wires connecting to the individual cells to monitor voltage. This black one that has a little teardrop on the end looking thing, that is a, you see that okay? That is a temperature sensor. So that's how the circuit board can monitor the heat of the pack, and if it starts to sense that things are getting dangerously hot, it can cut off the flow. And the Ryobi ones, they use a pair of Mosfets. In every one of their batteries so far that I've taken apart, I've got a bunch of examples. This is a P107. This was a P104. I've got P103s over here. In each of those, mi amor. Mi amor.
Sorry, you're filming?
See?
Oh, I'm sorry.
It's okay?
Oh.
Is it okay if I'm filming right now?
Yeah. Let me go upstairs.
Okay, baby.
Okay.
Sorry, wife was coming down on a speakerphone. Yeah, so I've got a handful of different models I've taken apart, and they're all similar to this layout. with 2 primary MOSFETs mounted on fairly chunky metal heatsink. Some are bigger than others, but this is the general design that Ryobi has been using. They're all very similar to this that I've seen so far. Some of them will use nickel strip instead of lead wires for the balance detection, but and there are different revisions of this that have slight differences, but this form factor is more or less what they all look like. So you can tell immediately that the circuit board is significantly smaller on the official Ryobi version. And this heatsink, this mask back here for the MOSFETs, is significantly larger. And this is, some of these other models have significantly bigger ones on the Ryobi officials. So this thing, you can see these MOSFETs. There's 6 MOSFETs, and you can see there's a very large, pointless something. This whole area is all a big copper plane, probably ground, I'm guessing. And it's got lots and lots of vias stitching it to the other side. So that's what they're relying on for heat dissipation, is all this extra. Oh, it goes all, this looks continuous all back here. Yeah, this is all pack negative. That looks continuous all back here, all wrapped around. Yeah, that's all ground, all one big plane for heat dissipation. That's a lot less thermal mass, and so depending on how efficient these MOSFETs are, that could be an area where this may fall short if you're on a tool that uses very high current. I also see they've got, on this side, they've got a piece of insulator covering these connections, but they don't on that side. Does that line up with something? Ooh, no, this goes this way. Yes, so that goes right behind this spring. So that's clearly there to stop those from contacting. On this side, it's just one connection touching, so there's no risk of shorting. So that's good. So they've definitely made a lot of reasonable safety decisions at first glance. I can see here, I don't know if this will show, right here, this red wire, which is marked 16 wire gauge. You can see this has been pinched. It's got a divot there where it's being pinched over this chip. What is this? Oh, those are diodes underneath it. It's being pinched against those diodes by the top cover. Diodes that hopefully don't get hot or too hot. This feels like silicone probably, which is good. And this other one is also 16 gauge for the negative coming off the circuit board. Let's identify some of these chips on the Kunlun. I'm not sure if I'm pronouncing that right. Kunlun. I'm sorry for being ignorant of how to say that. Let's take a look at some of these and see what they are. Okay. So I can see it looks like there is conformal coating over everything. It's all got that kind of shiny appearance. That said, I can trigger this button by touching its contacts, so they must not be fully covered, or maybe this button was installed after the conformal coating. Oh no, actually I can tell in the glare of the light, the conformal coating doesn't quite cover all these contacts. It sort of goes, I don't know if you can see this on camera, it's sort of, you can see kind of the puddle of the coating kind of goes around here, and does like that on this part. I can see a big splash of the conformal coating right there. I can see where it was brushed across the top of those Mosfets. Could be flux, or it could be coating over these two solder joints as well. And then these two resistors, but down here, I don't think I see any conformal coating on those. So they made an effort to do, you know, for some extra corrosion resistance on this, but they sort of got a little sloppy in a couple areas, and so now it's not, it could be better if that was fully protected over all these connections. That'd be better if you ask me, but not the end of the world probably. All right, sorry, we were trying to identify these chips. So these Mosfets are, gotta catch the light just right. There it is. RU4090L. And then underneath on the bottom of that, it says 934-0AD42. 0 Apple Dog 42. And that is the same on all of those. Oh, there's a revision. The circuit board has a model or a revision number here. It says RB18L50, which matches the model of the overall pack for them. It says version 1.2, PCB 2022-09-26. And this is September 2024 now, so 2-year-old design on the circuit board, which doesn't mean anything, just speaking. Let's see what these other chips are. We have, catch the light, this front chip here. It says that it's got the Texas Instruments logo, and that says LM339, and underneath that 21BWQ7YD. 21 Beta Whiskey Quebec, 7 Yankee Delta. And we're going to look at this chip next. Oh, that one's the other orientation. The shiny conformal coating on top of them can make it a little hard to see the... Okay, that says CellWise. Looks like a brand, CellWise. CELLWISE. And under that, CW1058. And under that, ALJPJ05Q. Alpha Lima Joliet Papa Joliet 0. Oh, that's not a 0. That's Q5Q. Quebec 5 Quebec at the end. ALJPJQ5Q. Okay. Interesting. And I can see a smattering of silicone glue down here, which would make me assume that there's probably a thermal sensor embedded in there. Oh yeah. Can I see it though? Let me get let me grab a headlamp real quick so I can see in there a little better. Where is that? Oh, here we are. Yes, okay. So you can see, well, that's probably too bright for you guys. Right here, you can see these two contacts labeled NTC. And then you can see it's, well, I don't know if you can see, but I can see it's got the two leads from that going down into the silicone puddle here, the silicone glue. So there is definitely at least that one temperature sensor on here. Is that light horrendously bright? I don't know if that was too bright. So yeah, so I can see its connections up here, and I can see the leads going down into that silicone goop. let's try to see if there's anything on the bottom of this board. I'd rather not take it apart for no reason. Like disassemble it from the cells, just because that would be, I'd have to unsolder these probably. And I'd rather not do that for no reward. Yeah, so I'm looking under here, and there are absolutely no components on the bottom of this board. Well, that's interesting. Yeah, there's no components on the bottom of this board, just some plastic guides for these components that kind of stick through some alignment holes. The only thing on the bottom of the board is the button to check the power. What I just noticed that was interesting, turn this off, is it's missing 2 screws. So there's a screw in this corner and a screw in this corner, and these 2 spots, which do have bosses, plastic bosses for a screw to screw into, they're just unpopulated. Interesting. I guess that saves a penny. It seems rather silly to me to save that penny. But I guess that's what they did. Why would they? That seems so silly to not include those screws. I'm going to open the other one and see if those screws are missing from this one as well, because that just seems like a very silly thing. A silly area to skimp on. You know? I mean, I guess every penny counts when you're trying to reach a price point that's lower than the first party battery. But that just seems awfully silly. You know, that will and also the 2 screws that they left off are the ones next to the main solder joints for the overall pack, positive and negative. I don't know if that could potentially affect those joints, you know, with more vibration coming in that area. I don't know if that would be something to worry about. Yeah, this is missing those 2 screws as well. Oh, okay. And this one is, well, I guess we'll just take this whole thing apart as well. Well, since I'm not taking the whole cells out or disassembling everything in any kind of destructive way, I guess this isn't bad. So this one, if I catch the light correctly, I can see that the conformal coating on this one, it's in pretty much all the same areas, but it's not hitting this switch at all. So I think maybe that switch is purposefully not a piece that they were trying to get the coating on. I think this one just splashed some of the pins for that sort of on accident. Oh, it's really difficult to catch the light just right to see everything with that coating. Yeah, some of these resistors back here near this temperature solder joint are not covered with that conformal coating at all. They missed them. And this one actually the same. Those 2, what is that? Capacitor and a resistor that's immediately adjacent. Can I find something skinny to point with? So those 2 right there, immediately next to this, are, geez, I'm totally out of shot. I'm so sorry, you guys. These 2 connections right here, or that capacitor and that resistor are not covered by the conformal coating at all. And the same on this one. Those 2 right there. Yeah, and this transistor, it's got conformal. Clearly they meant to cover it, but they didn't quite get the whole thing. So that top pin is not covered or not coated. Yeah, they're definitely trying to hit that competitive price point and cutting corners wherever they can. So let's put this one back in its box. Give it a quick once over for any kind of obvious stuff that's worth commenting on. Yeah. So yeah, that seems fine. Let's reassemble this guy. Whoops, we're gonna need the springs and everything in here. Yeah, so major, well, let's actually also see if this one's got the same cells. Oh, none of the writing on these cells is visible. Well, maybe down there. Trying to look down in there. Oh, is that it? Oh yeah, those are the same cells. Those are 2 amp hour cells as well. Yeah, so immediate first impressions after taking it or opening it up is there's a lot of reasonable safety stuff in here, as far as it's got all the leads to correctly check overall balance, or check individual cells rather, for getting overcharged or over discharged. Is that lining up? Why doesn't that look like it's going in right? There it goes. So they've got the balance connections, which is awesome. Definitely glad to see that. You can see, oh, you can see on this one too that the that same power line's got that same little pinch over it, over those diodes. Probably would have been worth it for them to just kind of put, you know, just a moment of effort to slide that over off those diodes like this and stop it from getting pinched, which would probably also stop so much heat. I'm assuming those diodes may get warm in use. So I would love to see just a little more care in it. Yeah, so right away they cut corners on skipping a few of the screws that their own design clearly calls for. The attention to detail on putting that conformal coating on is not great in a couple areas, which won't affect the operation of the battery itself. What that may affect is how readily some corrosion could form if you're in a humid environment with these. Speaking of a humid environment, does there? I don't think they do. I'm just seeing if there was any kind of ventilation holes through this at all. I don't think most of the official Ryobi batteries have. See, some of these do. Some of the official Ryobi batteries have little holes for air vents. And these holes, you can't tell, but those big Mosfets that this model has, so these, but actually bigger on this model, are right on this side. And so those vent holes are for some of that heat to escape, hopefully. But not all the Ryobi batteries have ventilation. I'm looking at this other one that I opened up to show you guys its guts, and it doesn't have ventilation. So not necessarily a big deal. What was I saying? So yeah, so that conformal coating missing a couple of those components, it's not going to affect the performance of them in any way. It's going to just not give those components the extra corrosion resistance in humidity, which, you know, depending on how you store your tools or store your batteries may not matter, but it's something that they clearly invested in to put there, and then just kind of dropped the ball at the last minute by not putting it in carefully. So I'm going to reassemble both of these. I will do some discharge tests to test what their actual performance or capacity measures out as. Obviously, they're calling them 6 amp hour, but they are clearly filled with only 4 amp hours. So and I'll have to look up the specs on those chips we saw, and look up the specs on if I can find exactly those 18650 cells that they're using, because I definitely would like to know. Ooh, that, I think I just stripped that hole a little bit. That feels like it's stripped, so that's unfortunate. I would say that this plastic is definitely a little less robust than what's in the officials. But yeah, so people are asking online all the, not me specifically, but not asking me specifically, but I see it discussed on, you know, Facebook groups and Reddit and everything. People are always saying, hey, I see these third-party batteries. Are they any good? Are they worth it? And most of the people that I've seen who have tried them have agreed with what we've seen so far, that they're frequently not quite the capacity that they claim they are. Yeah, that's loose. They are not quite the capacity that they claim they are. Just put this back together. These shells that I have that are waiting to be rebuilt, I just leave the screws and everything inside them loose, and then just put one in each corner just to keep everything together until these get rebuilt. So yeah, so most people that I've seen review these say they're smaller or less capacity than they claim, and their max output frequently is called into question. They can't sustain quite as high a current on what I've seen other people test, which is not this brand specifically. You know, I don't know if these are all coming out of the exact same factory and it's just, you know, a handful of different sellers accounts selling what are essentially identical product. But I have also seen people take apart these third-party batteries, and they're ultra basic on the circuit board, and they don't have any of the individual cell balance sensing or anything like that. So there's a lot less safety in some of these. This one, as far as that safety goes, that seems to look like they have implemented that, which is good. I will do, let's grab a tool real quick, just so we can see these, make something spin. Now, obviously, this is only at half charge right now. Yeah, that sounds like it's delivering the full, just about the full current that I would expect. Let's test, let's pop it into this. That sounds pretty good. Why don't we do a quick current test? Let me grab, again, my desk is largely in disarray, but that's okay. We'll make it work. Where is my other, there it is. Let's pull out a clamp meter. And what else do I need? I also need this. So this is something I put together a long time ago. Well, not that long ago, a year or so ago. I took a battery that had failed. The cells were bad. And I just replaced it with, took out all the guts, took out the circuit board, and put just a XT connector on the side that just goes directly to the positive and negative. What that lets me do is I can connect an AC adapter, a wall power supply, and power stuff from the wall if I wanted to, if I don't need to be mobile. But then I can also take this with an adapter, right? So I can plug the battery in here and run the battery to the tool across here. And this will let me put a clamp meter on this. These are 14 gauge wires. Put a clamp meter on this and see what kind of current the battery is delivering to the tool. Adding these extra wires will introduce a little bit of extra losses, so it's not absolutely perfect, but it should give us a pretty good idea. And I think this has a power switch on it, so make sure that's on. So let's connect our meter here. Can you guys, is that in the camera okay? There's kind of glare on that, huh? Let me hold that up a little bit. Okay, so we're gonna zero this, and when I flip this, we should see that current spike and go up. Here we go. So I saw that spike at about 15 amps initially and then settled down. So that spiked to about 15 amps and then came down to about 8 or 9. Let's grab, what else do I have over here? That's handy. Let's see, I don't know what this consumes for current. I do also have, I have an air compressor, a Ryobi air compressor, which I know consumes very, very high current. So we can, I'll test those on this, or these on that as well. So here is, this is a Ryobi drill. What is this? PCL 206. Okay, that's not great. That's not delivering very good current at all on this one. Gives a quick spike of about 11 amps and then cuts down to like 3 or 4. Let me grab a, yeah, so here is, I think this is fully charged or close to fully charged. Oh, we can check it real quick. 20.5 volts, that's fully charged. So we can connect this one. Whoop, did I do something? Get that on there. Let's see what the official, well, okay, now this is not official Ryobi. This is a Ryobi circuit board, but my aftermarket cells that I put into it, which are name brand cells. They were either Samsung or LG, I forget off the top of my head. Let's see what that produces. Oh, okay. So maybe that's just all this consumes. Okay, so never mind. Maybe this drill just doesn't consume the current. I thought it did. This is the Ryobi 1-gallon air compressor. What's the part number on this? P739. And again, these are only at half charge the way that they are right now. So I'll do more testing later, but just so that I can get a little bit of this footage in on the on this first video. So let's do that. Zero that. It's gonna be really loud again. I'll mute all of these while they're running. And here we go. Well, let's make sure that cord is right where we want it. Okay, ready? Zero that. Here we go. That seems low. So with this battery, which I know is about fully charged, it's holding around 8 amps current. And with this one at half charge, it's holding like 7.5, 7.7. So given that it's at half charge, that might not be too bad. As far as its current delivering capacity, how long it can maintain that may be a question. So I'm going to definitely test the long-term current draw on that, or current delivering capacity. Okay, so the only other thing to check real quick is just that they do indeed seem to charge with a regular Ryobi charger. Yep, and you can see right away that went into charging. Try this one. That double blink means it's communicating, and then the slower blink, immediately it's charging. So I will charge these up. I'm going to use this nice, slow, gentle charger. Give these guys every benefit for their discharge performance. Yeah, we will follow up the second half of this video with how they do in their discharge. And then I will record some final thoughts. See you guys later. Alright, so these have had a chance to fully charge overnight, each of them on the slow Ryobi 6-watt charger, which is one of these little cap chargers. These are only a 6-watt charge, which is very slow, very gentle. It really is ideal for your batteries if you're not in a rush to charge them at a lower rate. So I use that so that we are not abusing them at all out of the box. They are going to have the best chance of performing at their top potential. So the onboard battery indicators are showing full. Let's check what their final voltage is. 20.3, 20.5, so that looks right. These appear to have successfully charged up. We're going to use what we have right here is a constant current load that we can use to discharge these and get some measurements on their capacity. Let's reset those measurements to 0. I'm going to connect it with this this adapter here that lets me just connect in everything. This is going through a 30 amp fuse with XT60 connectors that we just plug these in. And I will fast forward this part because it's going to be boring, but I will do both batteries and get what their actual capacity is. This load has a maximum discharge rate of around 150 watts. It's not pushing these as hard as some demanding tools will. Certain tools can really spike these higher, potentially spike the current draw higher than that. But for a sustained load from full to empty, we're just going to go as fast as this load will allow us to and see what we get. So I will fast forward this and we'll come back. Is that showing up okay. There's kind of glare on that, huh? How well that screen is visible. I think that's gonna have to be as good as it gets. Can we adjust the focus down? We'll go with that. Here we go. So the way this works, we're gonna just dial up the current. Adjust this display. Is that easier for you guys to see? I think that is. You can already see some of the voltage dropping as this goes. I'm going to set it right there. We're at 7.58 amps of constant draw, which at this voltage is about 151 watts. So we'll let this go. I don't have a minimum cutoff on the load tester, so whenever the battery tells it to disconnect is when it's going to happen. So we'll see what their cutoff voltage is in their circuitry. And this will fast forward. Okay. So that ended up measuring, you can see we were pulling a constant 7.7-ish amps, which started out at about 151 watts, and as the voltage declined, that same current draw meant that the wattage draw, the wattage of what was being bled off, would have reduced over the course of that. I'm going to unplug this battery. You can see we are getting one light now, which is what we'd expect. If we try to take a voltage reading, we can see it has rebounded up to 16 volts right now. Normally, if you don't know, normally during a discharge, especially if it's a higher current discharge, the voltage will sag during that discharge, and after resting for a little bit at the end of it, the voltage will kind of come back up, kind of rebound a little bit. Literal empty for a pack like in this configuration is 15 volts. Proper safety will have it detect that sag and disconnect the output when it reaches, due to that sag, a lot of them will cut out somewhere below 15 volts slightly. I'm trying to think of what I've seen the genuine Ryobis cut out at, and I've seen them cut out, I want to say like around 13 volts or so. See, it's rebounding slightly more now. So I will have to review where exactly this was sensing the voltage at. Now keep in mind, this thing is detecting the voltage on this end, in same terminals that it's doing the discharging from, which means the voltage that it reads here after going through some wires may be lower than what the actual voltage at the cells is, where this circuit board can see. So really, you get the most accurate reading directly at the cells, as opposed to at the load that's discharging them. But you could see the voltage went to 0. I bet if I reattach this, yeah, it's reconnected now. So that safety circuit did its job. You may have seen I don't know how fast I'll have to fast forward that. That took about 30 minutes, so that may just be a blur to you. But I felt the pack several times during that, and you know, looking for anything that felt like it was getting hot or overheated. It is slightly warmer than it was initially, like ambient, but not at all hot whatsoever. Definitely nothing, you know, barely noticeable warmth. You know, if you weren't sitting there monitoring it and looking for it, you probably would say, no, it's not warmed up at all. But I can feel a bit of warmth here. So on the bottom, that could be the cells themselves getting a little warm. But you may also remember the Mosfets that they're using are all directly under this top section here. And I'm not feeling any warmth at all here. The only warmth I feel is a little tiny bit on the very bottom, really. So that was really successful. It's supposed to be a 4 amp hour battery according to the cells that are in it, not according to the label. We know already the label is an exaggeration. And it came out at 3.91 amp hours, which is pretty close. Again, because of that voltage sag, the higher the current that you discharge it at, the lower capacity you'll measure. So if we were discharging at a slower rate, there wouldn't be so much sag, and we'd be able to discharge this battery closer to its true empty level of 15 volts. You could see already it rebounded to 16.1 volts is where it's rebounded to. So that's another volt of capacity we could draw off of it if we were at a low enough current as to not sag it below its threshold. So the safety cutouts definitely did their job. I'm going to take this apart now, and I'm going to let it sit for a few just to cool down completely so there's no warmth at all. And then I'll take it apart and we'll see how evenly the cells discharged. We know they were pretty much right where they should be for balance at the start. One charge and discharge cycle would not be enough to throw anything wildly out of balance at all if they're all healthy, well-matched cells. So this will just be kind of a sanity check just to see that none of them are wildly different than the others that are in there. So let's do that next. I will also do the same kind of discharge on this other one at a lower rate, which I won't bother filming and showing you because it's going to be the exact same boring fast forward of the first one, basically. So we will do that. I'll do that off screen and comment it down below or in the next segment if I can remember. And we'll take a piece of tape here, find the end, and we will leave ourselves a little note. This was 3.91 amp hours at 7.75 amp draw. So that's what the capacity of this one came in at. Clear this thing's memory, and I will go ahead and set this aside to start discharging the other one at a lower rate. Plug it in. So this one's starting out at 20.3 volts. And what do we want to discharge that at? We did this one at 7.7. So, which is a pretty reasonable limit for common tools. Again, some tools can go quite a bit higher, up to double that, potentially. And still not even being like the HP line of Ryobi batteries, the high performance stuff. Just the regular batteries can go up to 15 amps continuous. So let's do this other one at 3 amps, I think is what I'll do. I'm just going to push this back and we'll see what its capacity rating comes in at 3 amps. Set this. Whoop, that's 3.5 amps. There we are. So it's at 3 point, I guess that's off camera. So I've got it set to 3.04 amps, which at the full voltage is currently 60 watts starting point. You can see that 20.3 volts already is sagging down to 19.7 as measured on this end. Oh, and in case anyone's curious, these wires on the adapter that I've got on the battery are 14 gauge. And then from the XT60 connectors to the load, these are 10 gauge. So we shouldn't have, there's no significant losses happening in these wires. There is some, it's not nothing, but not enough to skew anything in a meaningful way, and none of these wires got warm or anything like that. So pretty much all the energy's getting to that load for measurement. So let's disassemble this and check how evenly those discharged. And then I will play with these a little bit in a couple tools, just kind of see if I notice anything noteworthy, just kind of from feel, from using them in a few tools. And then we'll record some final thoughts. And I'll also record a segment where I review. I've still got to look up the part numbers we saw on the circuit board and on the 18650 cells. So, ooh, what just happened? Oh, that's interesting. So one of the contacts, positive contact, just slid off of its little holder here. Those are just a gentle friction fit, apparently. Is this one the same? Yeah, oh, okay. Yeah, so those are easy to remove. That's a just kind of bent over the top and a bit of a friction fit. It's got a like a little notch in the bottom to kind of guide it into position. Interesting. So that is a little, if you're taking this apart, that should be a little bit worrisome, because the positive side of this is not switched by the Mosfets. The negative side is. So this side is always connected directly to battery positive, and if this were to fall down when you were opening this up and accidentally short something important, like if it were to tap this or whatever, that could make some significant sparks and be a concern. So let's, so before we go forward, let's just put a piece of tape over that as a precaution, because I really don't want to burn my house down. So let's take a piece of Kapton tape. Kapton is a brand name. If you're looking for this online, this kind of tape, you might find it under, I think polyamide is the generic name for it, polyamide tape. They all pretty much look like this yellow translucent stuff. And it's just a very heat resistant insulative tape that that's useful when you're working with batteries or cells to insulate stuff or cover stuff. It's very thin, so it doesn't take up a lot of real estate or thickness, and it'll keep your battery safe. And because of that heat resistance of it, whereas regular electrical tape, if it gets very hot, will tend to melt and shrink, this has much higher limits for temperature, so it's very safe, or much safer. Not that I know exactly what its limits are. But yeah, Kapton with a K is the brand, and polyamide, I'm probably pronouncing that wrong, is the generic. And I'm just realizing as I'm talking and doing this, I said I was going to let this cool down all the way before I started, and I totally forgot about that. So I've already taken it apart. I can feel the warmth. It's not nothing, but it's not anything to a concerning level. It's it's really fine. It's warm but not hot. So let's get a meter over here and we'll check these values. Set to DC voltage. So first set, you can see we are at 3.1 volts, 3.26, 3.26, 3.26, and call it 3.20. Oh, there it goes, 3.2. So not perfectly balanced, but still close enough to one another that it's not immediately concerning. Yeah, I don't feel any warmth at all up here on these Mosfets. None of this is warm. The only warmth is the cells themselves got a little warm, which is normal. It's gonna, no matter what cells you're working with, they will warm up during discharge. And the reason the Mosfets, especially on the Ryobi ones, have that large heat sink is because it's really not uncommon for those important components where all the current's flowing through to warm up as well. It's not concerning that it got warm. It's pretty normal. How's this go? Yeah, so I'm just looking for, it's interesting. So they maintained, the outer profile like the Ryobi official shell, but because they don't have the large heat sink on the back or anything, this is all just hollow. And they've got this plastic cover covering the cells, and that rides up against these bosses that are really holding it there, and it doesn't really have any play at all as far as vibration stuff to worry about. So not bad. Yeah, I'm not displeased with that. So I will carefully unwrap this now, put it back where it belongs. Oof, I made a mess of that. There we are. Put that back where it goes. Obviously with the tower portion on top of this, it stops those from being able to slide off of there so easily. And to be fair, these are not really something that most people ought to be disassembling in any way. So we'll get this put back together and I'll talk to you again in a moment. All right, I think next step is to look up some information about those chips we saw, and then I'll be back. Okay, so let's do some review of some of the components that we saw during the teardown and do some final thoughts after some testing. So first, let's talk about some of the components that we saw. I printed out some of these sheets so that it's a little bit easier to go through them. The CellWise CW1053 I think during the teardown I called it the 1058 because that's what it kind of looked like. But when I went to look for the data sheet, I couldn't find it, but this was coming up in its place, and so I went and looked again, and it is actually the 1053 chip. I was just reading it wrong before the glare or whatever. So these are from a company called CellWise. They seem to do a lot of different battery protection circuits. So it seems like something that they're well known for. It's a large part of their product offering is these battery charge circuits for various series arrangements of batteries. This one is specifically for a 5S pack, which is what these types of batteries are. And they include overcharge and over discharge protection, as well as a little hysteresis cutout so that you don't have it turning on and off or anything, which is normal for well-made chips for this. So they'll cut off at 2.3 volts on the low side, and for the overcharge, those will stop at 4.35 volts as a maximum, which are pretty good numbers. The 2.3 volt cutoff, keeping in mind you're going to hit that number while under a large load running most tools. So although you might measure 2.3 volts, as soon as your load cuts out, that's going to rebound slightly, probably to 2.7 or some odd volts at least. So I think that's a really fair number. I know 2.3, if you were on a low current load, that would be a little bit lower than you'd like. Most people I'll see not want to go below 2.5 volts if you read what most people prefer. But because it's going to be under a large load at the time, I think that's perfectly fine for this. 15 microamps normal consumption, 5 microamps when it's in sleep mode. So really efficient chip. There's a pinout. You can look this stuff up later. The batteries that are in it. So those appear to be, I didn't undo any of the welds, so I can't quite read where it says that they are EVE batteries as far as the brand name being on them, but I can read the ICR 18650 20P, and I don't know if there's pictures in this data sheet, but the wrap and everything matches. The parts that I can see totally match the pictures of this exact battery model. So I'm really confident without tearing the welds that that's what these are. And you can see these are rated for 2 amp hours each. And so having 2 sets in parallel, makes this a 4 amp hour pack. And these have a max continuous discharge of 30 amps. So there is plenty of current delivering capability out of those cells. They're a really good choice for a tool battery. I don't think there's anything else in here that's immediately applicable. If you're a nerdier type who can make sense of some more of that stuff, then by all means check out the data sheet for yourself. But all that I'm really concerned about is their nominal capacity, their regular voltage range, which is just a typical lithium ion range, 2.5 to 4.2 volts. It's really standard. And their constant or continuous discharge rating at 30 amps. That's plenty. That's a really long data sheet for those, actually. Moving on, the RU4090L. These are the power Mosfets that they're using. I believe during the teardown, we said there were 6 of them in there. These are all, again, seem to be well rated for the task that they're in here. Their max drain to source voltage is 40 volts, and their gate to source voltage is plus minus 25 volts. And their continuous current. Where am I looking? Max power dissipation. They're depending on temperature. They've got a bunch of values in here, but they're in the range of 300 to 300 watts at 25 Celsius up to 200 watts at 70 Celsius. So that's plenty of room. Most tools, being in that, topping out for regular batteries in like that 300 to 400 watt range. And keep in mind they've got 6 of these going, so you're not just limited to the one MOSFET. And a maximum current on this is 110 amps, which is much higher rated than you'll ever see on one of these tools. So there's more specs that you can find in the data sheet for the nerdier amongst us. But yeah, seems well chosen for the task, and it seems to perform well. The performance of these things in tools, just anecdotally, some light use in tools, they seem to work fine. There's no significant observable difference from just a little bit of light use that I've done so far between these and regular Ryobi batteries. My thoughts on their quality-wise is, well, they're clearly lying about capacity. And the plastic that they've chosen for the housing, it feels a little bit more cheap, like a little bit more plasticky. I think brittle is probably what comes to mind. So I suspect, I'm not going to destroy these just because they're plenty useful still. I suspect that this plastic would not hold up as well to being abused. If you're dropping stuff or throwing stuff around, I don't think these would fare so well. But I think from the major components that we looked at, and the cells that are in them, as long as you're not going to abuse the plastic physically, I think they serve their purpose fine. If you know that they're a 4 amp hour battery and not a 6 amp hour battery, so that you understand what you're actually getting. This is the Amazon listing. They're selling these as a 2-pack for $59.99, and free shipping. So call it $30. This is US. The actual capacity, I did several discharge tests. As I drop one. Brilliant. What's this one? The one without the blue tape, its capacity averaged 3.90 amp hours. And the one with the blue tape averaged 3.64 amp hours. So they did average just a little bit lower than the 4 amp hour theoretical full charge. Again, there's a couple variables into that where depending on the discharge rate and everything, you're not necessarily going to get the full charge. I did one discharge at 3 amps, which is a fairly low current for these, and the rest I did at 7.75 amps constant current discharge, which is a little bit closer to a regular tool. So $30 per battery. Comparing that to a Ryobi 4 amp hour battery, these are a little bit cheaper. I think the Ryobi batteries right now are for a pair of 4 amp hours. And again, Ryobi batteries do go on sales and specials and promotions pretty often. Not constantly, of course, but unless you're in a rush, you can kind of hold off and wait and catch a special and usually get more for your dollar, or the same thing for less dollars. So with that in mind, it really just depends on if you think that they're worth it to you for the price. If there's not a promo going on with the regular Ryobi batteries, then I would say, unless you are going to be really hard on your tools where you need kind of a more rugged case, I think these are fine. If you're just a homeowner, DIY or whatever, I don't have any problem with these. I intend to keep these and use them, and enjoy having two 4 amp hour batteries. Yeah, I don't have any concerns with that. They do have, if you go on, I'll have links below. I don't think I've got any of it included in what I printed. I've got they've got a these Ryobi 18 volt equivalents. They also have Ryobi 40 volt equivalents, or 40 volt compatible, and they also have several other brands compatible with other brands, DeWalt, Craftsman. There's a handful of them. I will assume that their capacities are probably overstated as well on the other ones, but I have no way of knowing without seeing them. I did message them about these. They claimed that the different plastic, the weaker feeling plastic, improves heat dissipation. Maybe that's true, but I'm inclined to think it's probably just nonsense and it's just cheaper plastic. And then they also said, oh, we'll have to touch base with our manufacturing facility about the capacity discrepancy. And that seems like nonsense to me too. I'm sure that I don't believe that they didn't know these were mislabeled capacities. So, but again, even if you know it's a 4 amp hour battery, if there's not a sale going on, these are still cheaper than the Ryobi official ones if you're just trying to get a couple batteries and not taking advantage of a big promo or sale at the time. So overall, yeah, I think these are fine for around the house use, DIY use. Yeah, and that's my opinion. I do want to say, just in case when I edit stuff after this, if I don't have it said somewhere else, these batteries were sent to me for free. This company, again, I don't know how the right way to say it is, Kunlun. They emailed me, said they saw some of my other Ryobi batteries on YouTube and were interested in sending me a sample and doing a review. I told them I would be happy to, and they said, pick one of the batteries we have on our store and we'll send it to you for free. And they did. I said, well, I've just recently rebuilt some 6 amp hour batteries myself, so this would be perfect. I can compare them. Obviously, these didn't end up being 6 amp hour, but so they shipped these to me for free. I don't have to return them, so that's the only monetary value I'm getting out of this. They didn't pay me anything beyond just sending me the battery packs for free. And they are not, they didn't give me any kind of scripts or talking points or anything, and they are not reviewing this before it goes out. It's, completely my own genuine opinion. They just wanted to see, they just asked me to make a video, and there was no rules attached to it. So this is what I find. Yeah. Trying to think if there's anything else worth mentioning right now. I don't think so. Again, they just seem totally fine. Aside from overstating their capacity, they do their job. So I'm okay with things. Yep, that's it. All right. I'll get this edited and send it out soon. Thanks, everybody.